Hello everyone, this is Tareen Khan. I'm going to give an overview of our LiFePo4 cell inspection. Basically, we have received a delivery of 32 pieces of 304 amp hour EVE cells, and we're going to do a physical and electrical inspection. Uh, LiFePo batteries are one of the best lithium batteries you can get. Basically, that's because of its low cost, low toxicity, long cycle life, non-explosive nature, high heat tolerance, and other factors. They're used quite a lot in electrical vehicles as well as utility scale power applications. They're also cobalt free. Finally, they're 3.3 volts or 3.2 volts, depending on how much they're charged up. Usually, they're combined to make higher voltage battery banks. They can actually range from 12 volts to all the way to 96 volts or up. Mainly for our battery backup system that we use at home is going to be 48 volt or 96 volt configuration. And they're usually controlled by a battery management system which contains hardware and software to control battery. For this video, I'm only going to really focus on the physical inspection and the voltage verification to make sure all of the cells are of good quality, that they're new, and they have the correct voltage, and they're basically matched cells, meaning that the voltage are very similar to each other. So a little bit about our company. Mainly this is going to be related to Solar 2SK, which is in the residential and commercial solar equipment installation, as well as battery storage project. I'm not going to go through all of this, but we do have multiple different companies and brands that is related to different type of project areas that we focus on. Alright, so just a little bit about me. I'm currently serving as Chief Strategy Advisor and Chief Operating Officer of Solar 2SK, as well as CEO of Solar 3K, Yellow Star Power Ltd CEO, and Solar 4K, among the other companies. Just didn't list it over here because that was just too many companies to list, in all honesty. In my previous life, I was a software engineer, as well as I did get my graduate degree in system engineering and management from UT Dallas. So I am also very much into paying attention to detail, which is why this page from LinkedIn has been copied and pasted together because I did not quite like the looks of it. So you might get a hint of it in my future videos that I make, that I sometimes do get obsessive about trying to get all of the details of a project right. So let's go ahead and have a look at these battery cells and see how they are. Alright, hello, this is Tareen with Solar 2SK. So I am going to be verifying the new battery cells we have got. As you can see, they've come in the box. I'm going to be going through all of these and verifying that they're the right voltage and they're actually new. So I'll be physically inspecting them and then checking the voltage of these. There's 32 cells in total, about 32 kilowatt hour. So this is what one of these cells looks like. Looks new. You got a QR code on it to get you more information over here. And the positive and negative connection. And the vent right over here. So it looks fairly new. Actually, it looks very new. I don't see anything wrong with it. So I'll be going through all these battery cells one by one, physically inspecting them. to make sure they're in good shape before we connect them up to a battery management system and seeing how that works out. So all the cells in that box looks new. So I'm going to keep on opening the rest of the boxes. There's about 8 packages I'm going to go through and check out. Alright, okay, so I'm over here going to be testing out the 32 cells. I'll just line them up over here and go through them one by one. Alright, here's another box I've opened. Again, verifying physically that they look fine. Also, I'm making sure all of the positives are on one side. That way, I can easily go through all of them. So the second box batch looks good. So this is a third box I'm opening. This also is looking fairly good. Okay, so far it looks like the other thing that did come on with the package are lugs, basically bus bars, and the nuts for these batteries. So I am going to be collecting these. Alright, now I'm working on getting the fourth box out. So again, physical inspection. Looks new, don't see a problem. Alright, I've repositioned the camera a bit better as we continue opening the boxes. So let me go ahead and finish the physical inspection of the battery cells. Over here we do have a lot more battery cells to go through. I think we have about another 12 or 14 actually. Yeah, they come pretty well packed actually, which is why it takes a while. So they're in these crates and they're fairly well packed, so it's actually hard to get out. So their shipping crates were pretty good. That's why it all came undamaged. So, but that's also why it takes a while to actually take out. Nice thing about this is it's fairly compact and doesn't really take up that much of space, even though it's 32 kilowatt hour. It's about 1.5 Tesla watt of power if you want to compare it with something. Actually, sorry, 2.5 Tesla watt of power. Alright, for the last one, since I'm out of room, I'll just have to line it up on this edge. And I think we should have enough space for that. Via voltage meter. So what I'm going to do is going through this voltage meter and checking out the voltage reading on all of this. It might be kind of hard to see. For the voltage, we're trying to make sure all the voltage are the same. So I'm going to start on this side with the positive and negative, and the black ones are actually positive. So if you hold it here, it's at 3.229. Let's see if we can show it better to the camera. 3.299. So I'm going to continue checking each one of these. This is 3.299. Again, 3.299. 3.299. So that's actually important because I'll put a hole on it so you can see the 3.299. That voltage reading is important because you want all of them match very similar voltage, especially in a group that comes together. So these cells are pretty good from what we have seen so far. I'm going to go through and test the rest of them, and they should be close to 3.299. Closer it is to 3.299, the better. Again, it's 3.299. 3.299. 3.298. 3.299. I'm just going back and checking all of them. This one is off by 0.001, which is pretty good still. All right, 3.299. So this one is off by 0.001, which actually isn't that bad at all. So I'm going to continue checking all of this. 3.299. 3.299. 3.298. 3.299. 3.299. The last one over here is even harder to get to. So I'm just going to swap the sides. So this is also 3.299. This one is 3.298. 3.299. So all of these batteries are 0.001 off at the most, which is very good. So I would say these cells are all good physically and voltage wise. So I'm going to continue checking the rest of them. Actually, I already did that. So 3.98. 3.298. 3.299. 3.299. 3.298. 3.298. 3.298. 3.298. 3.299. 3.298. 3.298. Alright, switching sides. 3.297. 3.298. 3.297. This cell is probably the only one that's actually off a little bit more than others, and even then it's not that much that you will actually require a lot of balancing. I would say this cell has a little bit less power in it. That's why it has a bit of a lower voltage, which isn't necessarily a large problem since it's only off by 0.002. So let's keep on going to the rest of these. 3.298. Flip this up. Hold it steady. 298, 299. 298 or 299 rather. 3.299. 3. 298 or 299. So basically all of them are close together. The only one that I might actually charge separately is the one at that end, which is 297. Even then it probably can go without balancing since I'm getting an active balancer. So let me double check this again. Get a good grip on both the 297, sometimes 298. It does fluctuate a little bit, but I would say these cells are good to go. And I will be looking at hooking this up to the BMS and then doing some testing once we're ready to hook up. Now I'll let you know how this goes. These cells, like I said, looks good. Quite a lot of power, about 2.5 Tesla Powerwalls worth of power. And they're fairly compact. As you can see, they actually fit on this bench that we actually put together a while back. So I'm going to actually zoom out so you can see the entire bench. So this little structure we had put together a while back. We built it ourselves and we put the bench in. And this battery, the 32 kilowatt hour, actually fits on this bench. This is actually meant to be an outdoor bench type equipment that we are looking at over here. Another look at the bench over here that we have all the batteries on, and a close look at the batteries. One last look at the voltage reading. All of the cells are 3.299, 3.298 or 3.297. So it's fairly close except this one cell. I don't think this needs to be even balanced, but I would say this set of battery cells are good to go. The reason it's fluctuating is because I'm not holding these against the battery. And it does get loose if you don't hold it right against the battery. So we will hook this up to the BMS and test it out in the next few days and see how it goes. Should be fairly good, these battery cells. Thank you for watching.